So now we're moving on to conditional proofs 7.5. For this video, I want to go over how to set a conditional proof up and how it essentially operates. And I'm going to be going over a few examples. And in the next video, I'll do some from scratch for you. So a conditional proof is a different way to do proofs. Using the CP will always get you a horseshoe statement. So the best time to use it is when your conclusion is either a horseshoe or a triple bar. But you also know that if you have a wedge, you can turn a wedge into a horseshoe using implication. So this is where it's time to just take all the knowledge you have about all the rules and different ways that you can apply them. But if you have a horseshoe or a triple bar as your conclusion, like we have right here, absolutely 100% go for a conditional proof. Okay? So a conditional proof is if you had P, then you'd have to have Q. So this is how a conditional proof is set up. This is your premises they're giving you. This is the conclusion, just as the same before. The difference is now we're going to indent. Notice how all of these over here are indented. And the first line of your indentation is going to be an assumption for the conditional proof. And that's A, C, P. And now the assumption is the antecedent of your conclusion. So notice the A is right here. So what you're going to do is, assuming that A is true, can we get to the consequent? So using this as an example, let's just run through this. So we're going to assume A, and based on this assumption, we can still use everything up here. So we use modus ponens with 1 and 2, and then we get not B, and then we get not Z. Conjunct them together, and then we'll just do De Morgan to take the negation out. Now, I want you to notice something here. First line, right here, absolutely has to go right there. Second, this last line, absolutely has to go right there. Okay? So what this means is the assumption for your conditional proof, and then the last line of your conditional proof, that sets up your entire conditional proof. Okay? So when you come out of your conditional proof, notice how it's set up. And then everything inside of here, now that you have come out of that indentation, you cannot use any of this. So everything inside of here is based on this assumption. So once you come out, you cannot base anything on that assumption anymore. So let's assume that we had to keep going here. If we did have to keep going, nothing inside of here, we can't use it. We can only use from here, here, and here. Okay? Of course, with this one, we're done. We got it. Just always remember, your antecedent is going to be your first line, your consequent is your last line, and then you come out of the indentation. Notice 2 and 8 are lined up over here. And then you just take this one down, and put a horseshoe between it. That's the only thing you can do with a conditional proof. Okay? And then that's what I'm describing here. So, the next one is showing you how you can do multiple indentations. So if you'll take note here, this conclusion, this is the main operator. So based on that main operator, this is the antecedent, and this is a consequent. However, also, you have another operator right here, which happens to be a horseshoe. So that means this is also an antecedent, and this is also a consequent. And that's how you set it up. So your first antecedent here is right there. And that's why it's indented. And then indent again and set up your second antecedent. Okay? So if you can have multiple of these, and I'll show you that in just a second, and you can just keep indenting. Please keep in mind though, when you indent this many times, so you have 1 and you have 2, you have to come out that many times as well. So you can't end your proof inside the indentation. It has to be completely out of the indentation, because if you're basing it inside, you're basing it on these assumptions. You can't do that, okay? So look at it this way. Now that we have our not Z and our M here, this is actually our goal. And once we get our goal down here, as you can see, then you can discharge from all of these, and then you can end up with your answer. So you're going to have your not Z right there, the M to the not Q be right there. So you have to keep in mind that when you are doing these conditional proofs, you actually have a different goal in mind. The goal is not this entire conclusion anymore. Now the goal happens to be not O. And always keep that in mind, okay? And also, as a side note here, you can do more than one operation on one line. I'll allow you guys to start doing that now that you've taken your exams. You should be getting pretty proficient at these. So I'm totally fine with you guys taking little shortcuts like that. Okay? Okay, so let's show you some bigger ones here. So as I promised, this is one where you have multiple antecedents. So notice that they're always connected with these horseshoes, except for this one. Sorry, this one. Okay? So what you want to do is find your antecedents. Antecedent, 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 antecedent. And then literally start stacking them. Just remember, you have to go and indent every single time. And these all become your assumptions for the conditional proof. And now your goal is Z. Okay? So that's just an example of how to set it up when there are multiples involved. And it's completely fine that you do it that way. Okay, so here's another example. So here we have our premises over here, and here's our conclusion, and we have one antecedent right here, and then that's the conclusion for the main operator. However, within the consequent, you also have an antecedent right there, and that's your consequent. So we're going to set it up. So here is our first antecedent, and here is our second antecedent, and then that is our goal. Okay? And you're still using all the rules, everything still applies. Just remember, whenever you're making an assumption, indent. So we have to indent twice because we're making two assumptions, and you have to discharge from it twice as well. Okay? Nothing's changing inside of these proofs, it's just the setup that gets a little bit different. And as I mentioned down here in the wording, I like to go like this to remind myself to come out of each one of them. I just couldn't figure out how to do that on Word, but it's nice to have lines here to remind yourself that you're not done with one, that you need to keep coming out until you have a line that's down here, okay? Alright, so let's go over the triple bar one. Okay, so whenever you have a triple bar and you are allowed to use a conditional proof, absolutely go for it, okay? So here, not only do you have a conditional statement inside as a premise, but you also have it as your conclusion, okay? So since we want to do a conditional proof, we're going to go on the material equivalence, and we're going to use the top one on that little sheet that I gave you. So you're going to end up with not M dot Z, and then you're going to put parentheses around that. And then this is going to be combined with okay, so if you do material equivalence for the conclusion, which is right here, and you do it over on the side, this is exactly what you're going to end up with. So what that means is I need to get this on a line by itself. I need to get this on a line by itself. and then I'm going to conjunct them together, and then I'll do equivalence in order to get there. So basically what that means is you need to break this down. So just look at this one right here and set up a conditional proof for that, and that's what I've done right here. I have not m.z as my ACP, and then I get to o.y, and then I come out, and then I have this one. And then I start all over again, and I start on this one right here. So I start with the o.y, and then I go to the not m.z, and then I come out of that and conjunct them together. Okay? Every single time that you do the biconditional as a conclusion, this is where you want to set it up. Okay, one more hint here. Let me get this all cleaned up here. One more little hint is, remember that once you go inside of this indentation, you cannot use it anymore. So if you have a triple bar as a premise, do the equivalency before you do your ACP, because otherwise you're forced to do it again and again. Okay? But if you put it up here, you get to use all of this inside of here and inside of there. Okay, so that's the general structure. Hopefully you also did the reading. Hurley has some really great examples, shows you how to set everything up. And the next one, we'll start talking about how to actually do these.